All right, Algebra 2, here we go. Rolling on 9-2. Oh, I'm sorry, 5-2. Get my chapters right here. Polynomial factors and zeros. Okay. Our essential question today is, what are the zeros of a polynomial function? Okay. Well, the zeros, they're the solution for when your function p of x is equal to 0. It's exactly like what we were doing with quadratics when we solved them. Okay. And we found x equal to 2, x equal to 3, whatever it was, where we set it equal to 0, and we factored it, and then we set each factor equal to 0, and we found x, and we found where the graph was going to cross the x-axis. Well, this is the exact same thing. We're just dealing with bigger factors as we go here. Okay? Just more things to factor because it's a bigger polynomial, higher degree. Okay? Those zeros are also called roots. Okay? And it's where your graph is going to cross the x-axis. Those are the zeros. Okay, and as you can see here, to find those zeros, is, like I mentioned, it's doing the same thing we did with the quadratics. Take your function, set it equal to 0, okay, and then factor it. Okay, just like I have right here. All right, so you're just going to look for greatest common factor in this case. Yes, it's a trinomial, but it's not a quadratic, so we're not going to use the quadratic formula or anything like that yet, because we got a third degree polynomial. But once you see that there's an x and everything, you can factor that out, and that's what's left over. That now is a quadratic. We can split up x and x. We've got a minus with a minus, so we're going to get a plus minus. Factors of 15 that differ by 2, 5 and 3, and 3 minus 5 gives us the negative 2, so the 3 goes with the plus, the 5 goes with the minus. And then set each factor equal to 0. Yes, x by itself here needs to be set equal to 0. X plus 3 equal to 0, subtract it over, you get negative 3. X minus 5 equal to 0. X is equal to 5 when you add it over. And if you remember, we talked about in the past, this times this times this has to equal 0. So one of these, or both or all, have to be 0. Okay? And what that means for us is that we're going to cross at negative 3, 0, and 5. Now, how do I know the graph looks like that? Because the end behavior we had in the last video, the section 5.1, that's third degree, so I know they're going to go in opposite directions because it's odd. Okay, and because a is positive, it's going to go down to the left and up to the right. So I just kind of roughed it in there. That's not a perfect graph. It does go through those points, but I just kind of roughed in the rest of it. Okay, so kind of think like that. Get that, kind of get that thinking of what the graph would look like. All right, so that's finding the zeros. Here's another example of finding the zeros where it's already in factored form. They've done the work for you. Just set each one equal to 0. So I know my graph's going to cross at negative 2, 1, and 3. Okay. Usually when there's 3 terms also, it's going to be a cubic, so you can kind of graph it the same way we did the last one. Okay. Write the polynomial function. If you're given the zeros, now we're working the other direction. Okay. Up here we had the function find the zeros. Now we got the zeros and we want to get to the function. Okay? Remember now, when we did this, we set it equal to 0. Notice that was a plus 2 right there, but I got a minus 2. That was a minus 1, I got a positive 1. That was a minus 3. When I add it over, I get positive. So when you put these back into the parentheses to try to find the function, change the sign back. Okay? Because that's like x equal to negative 2. To get it equal to 0, I've got to add the 2 over. I've got to subtract the 2 over. I've got to subtract the 3 over. So don't forget to change the sign when you put it back in there, because you're doing the opposite of this. To get this back over here, you'd have to add it to look like that. And then just multiply. FOIL the first 2. I combine like terms. The 2x is canceled out. I get x squared minus 4. FOIL again. Boom. Make sure the answer's in standard form. Okay, biggest exponent to the smallest. Okay, and you're in good shape. Combine any like terms if you had to. We didn't have to here. Okay. So that's writing a polynomial given the zeros. So it's just work in the opposite direction. I want to get a couple terms out of the way here also. Multiplicity. Okay? When you take your function and you factor it out, okay, if a factor shows up more than once, like this one here, the x plus 3 showed up twice, and you know that if x plus 3, we'd subtract it over, so we'd get x minus 3. We say that's a multiplicity of 2 because it showed up twice. If there was a third one, I'd say it has a multiplicity of 3. Okay, but in this case here, it showed up twice when I set them both equal to 0. So because it appeared twice as a factor, it has a multiplicity of 2. So if you get one of those x values that shows up more than once, then you start talking about multiplicity of it. It's just a term you're going to see, just be familiar with it. Okay, nothing that you have to mathematically do. And then the last thing here, last term we want to talk about in this section is relative max or min. Okay, you notice here on your graph, it's going up to infinity, it's going down to infinity, but you start having these waves in here. Okay, we look at these points here as relative maxes or mins. This point right here is what we would call a relative minimum because we're bottoming out here and coming back up. If you think about what we did with quadratics with min and max, okay, it's not the actual minimum because over here this graph keeps going down, okay, but relative to this section of the graph, that's a minimum point. Just like this is a relative maximum point. It's not a real maximum because the graph keeps going up over here. So if you're looking at range values for y, well, this goes to infinity this way and infinity that way. But relatively here, since we curved it up or curved it back down, they're relative maximum or minimum points. Okay? So, factoring a polynomial finds the zeros or the roots where we're crossing the x-axis at. And so we can solve just like we've been factoring and whatnot and set each factor equal to 0, find x. You can also take those zeros and work backwards and find the polynomial just by multiplying, and then multiplicity of a 0, and then relative min or max. Okay, we're going to look at this the next couple of days in here and look at some examples of that, some application. We'll get after that tomorrow. See you then. Bye.